Okay, so in this video we're going to be talking about Descartes' rule of signs. And the goal of Descartes' rule of signs is to gain info on all possible sign combinations for the zeros of a function. How many positive and how many negative do we have, and also it can tell us something about how many imaginary solutions we might have for the zeros of the function. So I thought it'd be good to go through an example to show you how to deploy Descartes' rule of signs, because Descartes' rule of signs can be a little bit complicated to try and explain generally or without a straightforward example. So the first thing we're going to be doing is, if we want to find all the possible sign combinations for this function f of x, we have to look and see how many times does f of x change sign between each term. So we can see here that there's a sign change here, there's one sign change here, there's another sign change here, goes from positive to negative, and then there's another sign change here, goes from negative to positive. Now the next thing we're going to be doing is you need to make a table like that, and we're going to have positive solutions, possible positive solutions, possible negative solutions, and then imaginary solutions. Now the number of sign changes in f of x tells us all the possible positive zeros that are for the function. So in this case there were 4 sign changes. Now after this you need to decrease that number by 2 until you hit 0 or 1. If there's an even amount of sign changes in whatever function you're looking at, then it's going to be until you hit 0. If there's an odd number of sign changes, it'll be until you hit 1. Now, in order to figure out all the possible negative zeros of the function, we need to look at f of negative x and see how many sign changes are in f of negative x. So if you look here, we got one sign change here, another sign change here, and then a third sign change right here. So we can see that there are 3 sign changes in f of negative x, then we just decrease by 2, and then we hit 1, and we're done with that part. Now, in order to figure out how many imaginary solutions there are, if you remember, the total number of zeros of a function is equal to the degree of the function, or the highest exponent that's contained in the function. So if you look here, we have a combination of 4 positive and 3 negative solutions, and that's 7 solutions. So in that case, there would be 0 imaginary solutions left for the function to have. Now if we look at 4 positive and 1 negative solution, that's 5 solutions, so there'd be 2 possible imaginary solutions left for that combination. Now we can look at 2 positive and 3 negative, and in that case there's 5, so there'd still be 2 positive or 2 possible imaginary zeros for the function. And we also have 2 positive and 1 negative, so that's 3 solutions, and there's 7 total, so that's 4 possible imaginary solutions. Now we also have 0 positive and 3 negative, so that again would be 3 solutions total for positive and negative, so that'd be 4 solutions for imaginary. And then we have 0 and 1, 0 positive and 1 negative, that's another combination, and that would be 1 total, so it could possibly have 6 imaginary solutions, or 6 imaginary zeros for f of x of this function. So I hope this example helped you on Descartes' rule of signs. If you have any questions, then leave it in the comments below, and I hope you guys have a great day. See you in the next video.